Hello there, and hello to you wherever you are in the world, and thank you for joining us for this special webinar, Pre-emption and Priority Revolutionised, where we discover how to give way dynamically and to different road user groups. In this webinar in the next hour, you will learn how to dynamically give priority to different road user groups, for which different road user groups this use case is already live, and how the traffic live exchange, known as TLEX, guarantees the quality of this use case. Now, we've got three guests to chat to us today all about this, so let's meet them now. Please welcome Steve Foyt, who's business developer in the Americas for Monarch. We've got Steven Bakker, who's senior sales consultant at Royal Haskoning DHV, and Christopher Halen, who's operations manager at vNotion. So together in the next hour, we're going to learn from these three experts, and we'll start with each of them giving you a 10 to 15 minute presentation, and then we'll have time for questions. Now, the way we're going to do that is you're going to post them, if you would please, on the Q&A button on your Teams screen, and I'll pick out the questions and put them on your behalf. So, as I say, all you have to do as you're listening is note down the questions that come to mind and put them into the Q&A screen on Teams. So, without further ado, let's welcome our first guest, and for the next 10 minutes, please have a good listen to Steve Foyt.
Thank you, Paul, and I welcome everyone. This is indeed a worldwide audience. I'm speaking to you from Seattle in the States. I think it's important to reflect on why it is we're here. And if you take a minute to realize that intersections are the point of maximum conflict in a transportation network, and that using the United States as a proxy, there's over 26 million ambulance rolls a year. If you take that number, which is over 70,000 per day, if you take that number and add transit prioritization, and that for pedestrians, bikes, freight, logistics, the scope of prioritization is truly enormous. And so, as Paul mentioned in this presentation, I'd like to help convey an understanding for what we consider to be a revolutionary shift in prioritization and how this works at scale. And we want to talk about how the shift simplifies for the authorities expanding systems to more road user classes on a larger geographic scale. And bear in mind that what we'll be talking about between Monarch and our partners is based on firsthand experience. We're doing this nationwide in the Netherlands currently. We have roughly 30% of the traffic signals connected to delivering information to roughly 25% of the vehicles on the road. And we're exchanging well over 1 billion messages a day. So a digital foundation is enabling truly revolutionary capability. And so it all starts with a connected signal. In the early days, of course, a single input channel would trigger a change to phase or an extension of a phase, and it required installing transponders. With the introduction of more complicated or more complex capable ITS modules, then more complex prioritization can occur, and those decisions were then made at the roadside or possibly in a centralized location. Today's systems are very advanced. They are cloud-based. They typically access dispatch, locationing, routing information, so there's no transponder necessary, and they use artificial intelligence and participate in corridor management. Our partners on this call are involved in this, as are other companies here in the States. For example, California-based Light is a very successful organization finding good penetration with an advanced system. And while these systems are advanced, there is a next step, and it is a revolutionary one, and that is to incorporate them into a cooperative approach. And through cooperation, there's some functionality that's unlocked. So consider now what authorities can do. They can introduce new road user classes and prioritize them contextually relative to other road user classes in the case of conflicts. They can add or evolve the choice of service providers that are providing prioritization and adopt a best of breed strategy. Data can be shared between stakeholders. For example, if an ambulance is prioritized through an intersection, why not announce to vehicles that are on the relevant street that there's an emergency vehicle approaching from behind so that they can safely make way? And these systems can be deployed regionally, even though policy is controlled on a local basis, which is important when solutions are cross-jurisdictional. I've mentioned a national deployment in the Netherlands. We're also embraced in the Flanders region of Belgium and also in the Nordic Way programs, where vehicles, infrastructure, and networks are connecting in Finland, Norway, Sweden, and Denmark, where safety hazards and road information is being shared among stakeholders. And when you consider stakeholders, and let's take a minute to do that, you have on the bottom infrastructure, whether it's owned by public or private parties. You've got the roadway authorities themselves and the infrastructure owner operators, people whose job it is to manage traffic, people whose job it is to plan and analyze traffic, and then the road users themselves. These road users are represented by a diverse set of service providers. So you've got people providing emergency and transit prioritization, but then new services and as yet seen services with regard to freight, vulnerable users, cyclists, vehicles, manufacturers bringing information into the vehicles, not to mention micro and shared mobility services. So with all of this, a foundation of interoperability is not only the opportunity, it's a requirement. And along with that come commercial and societal concerns where authorities are interested in controlling costs, controlling data policy, and road use policy. And I think all parties desire a competitive marketplace so that solutions are a best fit and there's no lock-in. So how do we help with that? Well, the first function I'd like to talk about is interconnection. And on the left-hand side of the screen, you can see what represents, I would say, today's silo approach, where solutions are acquired and deployed in silos. And they get the job done very well with connections that are made on a one-to-one basis. On the right-hand side, you'll see the revolutionary approach, which has at the foundation Monach's data exchange. This is a product that we call TLEX. It stands for Traffic Live Exchange. Having an arrangement such as this allows there to be one physical integration with each party, and any number of use cases can be deployed. So now former siloed solutions can be aware of what's happening with adjacent solutions, and the environment creates a very low friction area to increase scope of solutions or to add or modify solutions. You'll see our partners here, vNotion and Royal Haskoning. With vNotion on as part of this system, their ground truth can not only be accessed and used by prioritization, but could also be accessed and used by other important applications. Same for Royal Haskoning. There's no reason why corridor management cannot access and benefit from transit schedule information, for example. And with more stakeholders, validation becomes key. So consider a controller responding to a request. Two things need to happen. It needs to verify the request is legitimate and also in keeping with road authority policy. We enable this efficiently, despite the fact that there's now more actors and complexity in the system. We provide tools to manage this. First, we authorize the user via certificates and tokens. Then we determine what privileges the road user is entitled to. And at the heart of this is our policy repository. This determines who gets prioritized, and there are different levels of priorities. That decision, based on this information in the repository, the decision of priority can be made by the service provider or multiple service providers accessing this information, or it could be made within TLEX. It's feasible as well to have the decision made downstream by the signal system itself, but it's our preference that it be done further closer to the request itself in order to save on resources and to save on time. Now that dealt with where is a decision being made, where is a prioritization being made. Addressing the how is a very insightful view, and that is because historically policies have been input by road authorities at a rather low level, requiring technical skills, and these policies were then either difficult to share or it was infeasible to share them. And now with TLEX and the policy repository, entry can be done by a non-technical person, and it can be done at a desk. We start with the standardized map message, picture of which you see here. A map message, for those that aren't familiar, is a standardized view of a static roadway geometry. It shows the paths and the allowable movements. And with this map, you can then apply logical rules. And this is an awful lot like setting up your email box to process rules from different emails from different senders. So a truck with a certain kind of emission profile might get permissions at certain intersections during certain times of days. Or if an intersection is very, very close to a popular tourist destination, there might be prioritization given to pedestrians that is different from intersections that are without the tourist sort of burden. And so when that priority is established, and there are conceptually any number of different priorities that you could establish, this is used to solve, to execute road use policy, and it's also used to solve conflict in the event of multiple requests occurring at once. And that result is used then by the service provider who implements the prioritized request. Another way we put authorities in control is by supporting multiple solution providers. This is a view of Los Angeles County, and imagine a regional bus route that is to receive prioritization that cuts across the county. In this example, then, the cities that are shown in green are using one service provider, and the cities that are shown in yellow are using a different prioritization service provider. And with TLEX, the authorities can commit to participating in a regional program, knowing that they'll use the technology of the choice of their own choosing, and knowing that they will deploy their road use policies, even though it's on a regional solution. In addition to this, the regional authority, the transit agency in this example, can measure the quality and success of the solution across jurisdictions by understanding, because the system can understand when a request was made and also when the condition of the light at the time the vehicle arrived at the intersection. And so there can be quality of service monitored by the transit authority, even though there's numerous kinds of technologies and a variety of different cities involved in this. Now, for our partners, and we view partners as those folks providing infrastructure, supplying infrastructure, as well as solution providers, it's business as usual. There's no change to customer relationships or business models required by this revolution. There's the same logical interaction with other systems. We see it's just becoming part of a bigger whole and increasing value accordingly. And so the alignment is maintained with regard to authority interests that include safety and efficiency, as well as a trusting relationship and flexibility. And I'll say by way of context that the data exchange and this cooperative approach is really just part of the same ITS revolution that's occurring broadly across the world. It just happens that prioritization is often the low-hanging fruit. It's the first one. Here you see a journey of an authority implementing a number of improvements through intelligent transportation services. And so the next application might be real-time insights on traffic, or spotting vulnerable road users using vNotion cameras, or potentially improving traffic flow by Royal Haskoning and other vendors as well. And so our role is to provide the foundation for connected mobility. And with that, I welcome all to be in touch, and certainly appreciate your attention in our program today. Thank you.
That was terrific stuff, Steve. Thank you very much indeed. I've been busy scribbling down comments and potential questions for you, which we'll come to at the end of all the presentations. A reminder that as you're watching this, you can put your own questions in on Teams. Just click on the Q&A button on the screen. Now we'll come back to Steve in our Q&A in a few minutes time, but let's move on to our next guest now, who is Steven Bakker. He's Senior Sales Consultant at Royal Haskoning DHV, and he'll be talking to us for the next 10 to 15 minutes. So for now, Steven, the floor is yours.
Thank you, Paul. Hopefully I'm well visible and you can hear me via the microphone. Thank you for the opportunity to give a little bit of insight in some practical use cases that we have put to the street using our new, well, it's not so new anymore. Already we've been developing it for the past 6-7 years, but our sort of new intelligent traffic light software, Flowtech. So I'll be talking about how we are implementing local or regional or even countrywide mobility policy to the street. How do we implement those to road users? How to prioritize different type of road users, and how do we help municipalities or other authorities to bring their policy really to the street? Before we come to the practical use cases that I'm going to present, I'm going to take you a little bit to an introduction of what is our intelligent traffic light software Flowtech, but also what is the ecosystem that we live in with our software, and how do we benefit from the TLEX that Steve just mentioned before. First, I think it's a funny shot. This is actually a picture from the 1970s. It's a museum piece from the National American Historic Museum in Washington, and it's hanging there on the wall. And already 50 years ago, people were thinking about connected traffic management and how would that be in the future. Well, actually, we're now living in the future. If you compare it to 50 years ago, and we're now living that dream. So I think it's a good one to start this presentation. Our ecosystem at this moment. How do we see connected traffic management at this point? So we see a lot of need for municipalities or other authorities to prioritize different kind of modalities. Could either be emergency services, public transport, but also in cities, you see more and more that cars becoming less attractive, and people want to give more priority to slow road users, such as bicycles or pedestrians. What you see here is the sort of ecosystem that we've created within the Netherlands and also in the Flanders region in Belgium with the Talk and Traffic program and the Mobility Data program, which are quite similar. And we've created a data ecosystem where we all benefit from data that we share with each other in a closed and privacy secured system, which is handled, of course, by the TLEX of Monarch. Without going into too much detail technically, but in essence, it's data brokers and information services such as Ocean with their cameras can put in data in that cloud environment, and we as a intelligent traffic light software system, we can pull that data from that cloud service in order for us to use it in our day-to-day mobility management system to bring the policy of the road authority to the streets. So what is Flowtech in a nutshell? I think you all mentioned or noticed sometimes that you are standing before a red light and you're thinking, well, there's no traffic on the right side, no traffic on the left side. What am I doing here before a red light? And that's mostly due to the current way that traffic lights are programmed. So you have a static time. Let's say we have a minute, and every direction gets 15 seconds of green time. And when there's a priority case, then it will immediately be cut off, and the whole circle starts again. When our talk and traffic program started in the Netherlands, we decided to do it radically different. So we decided to put all the software inside a cloud service, and every second with Flowtech, we calculate the best way to handle traffic at that moment on an intersection, on a corridor, or in a city network, based on the data that we receive from the ecosystem, but also we take into account the mobility policy that's currently being presented by us to the different kind of road authorities. And all of those parameters, our algorithms starts calculating. Every second, it will do more than 30,000 calculations for them to for the system to make the to optimize traffic based on the policy of the local municipality. What we see now in municipalities that don't work with this systems yet, it's quite siloed. So you have the policymakers, you have the traffic managers that are all working in silos. And with our software and with our new philosophy of the preemption that we are talking about, we try to bring those silos together in one ecosystem within the municipality or within a road authority. So from there, we can bundle the strengths of both the strategical, tactical, and operational people for them to make sure that the policy that they strive to get on the street is being handled in the correct way. But also, it gives the opportunity to get very much more informed of what's going on the streets by using real-time data, but also communicating back towards the road users what's going on. We now already have use cases where we can proactively talk to car users in their in-car systems that they're going to have a green light in 11 seconds when they slow down driving at this moment. Those kind of systems you can think of that are already active at this moment. So with that ecosystem and the bringing together of the policymakers and also the operational people, the whole ecosystems is still the same, but it changes the way it works and how the road users are benefiting from it. That's a very short introduction about Flowtech and the way we see that we bring the policy to the streets. We'll now go to the different use cases that we already have achieved, and we will take one city in the Netherlands at this moment. We have 40 intelligent traffic lights running in the city of Deventer. It's a little bit in the east of the Netherlands with almost 100,000 inhabitants. And they have defined numerous policy goals that they want to achieve. When there's time, I will talk about this World War II bomb. But first, we go into a little bit other use cases that are more aimed to prioritization. So one policy goal is that they want to improve the throughput of certain corridors. So how do they achieve that? So with the video that's playing now, you'll see the dots lighting up, and those dots are connected vehicles. So either they are connected with an app or they are connected with the in-car system towards the ecosystem that I described before. And because they are giving their data towards that system, we can see them inside our software, and we can, and because we see them very much not only 50 meters before they are at the intersection with the standard sensors that we have, we can already see them 200 or 300 meters beforehand because they are actively sharing their data. And because we see them earlier in the system can calculate, okay, this person is going to be here in 18 seconds. I know they're coming, but I'm going to push through these cyclists first. Because I know I still have 18 seconds to spare time to give them green light. And this is a way to dynamically optimize traffic and guarantee certain throughput that the policymakers are aiming for. Another example that Deventer has is they want to reduce the emissions that are being produced by logistical trucks. So Deventer is a big sort of logistical hub in between the Netherlands and Germany, a lot of industrial sites, and they have a lot of emissions flying through the air because there's so much trucks driving there. So and every truck stop that you can prevent will save 0.5 liters of diesel, which also equals some amount of emissions that are being put out in the air. So we have done done a few pilots, but also in a practical way where we give truck drivers an app where they can when they are connected with the ecosystem, and when they are connected, we see them coming and we guarantee them green light. So in this case, the video is playing. You see a star. The star is the truck, and the aim of the software is to make sure that the truck doesn't stop, because that will cost him the 0.5 liter diesel that I just mentioned. And we try to give the truck a smooth flow towards the highway so that it can easily go into that system and not pollute extra than it needs to. So that's a practical use case that we are actively doing now for example, in Deventer, but also other cities are already active with using that. Another practical example is safety for emergency services. In the Netherlands, we still have more than 80 emergency vehicles that have accidents on intersections every year, and that's mainly because they need to drive through red light when they are in a hurry. So then some people don't pay attention and collisions will occur. Our system, because those emergency services are also connected towards the ecosystem, we can see them coming. We know their route, and the video is playing, and it's a star. And because we know their route, we will plan them in and give them green light on the time that they will reach the intersection. This makes sure that they arrive faster on the place they need to be, and that's of course important because some people are in need when the emergency services are coming, but also it guarantees green light for these emergency services, and that prevents them from having an accident, which what I just mentioned still occur in the Netherlands, but also in many different countries, of course. Because, well, there's no intelligence behind this prioritization yet, and we have this. We can facilitate this at this moment. So that's regarding safety. Then another one that we have is regarding health. So the city of Deventer thinks it's really important for their people to be healthy. And of course, we Dutch people are tend to jump on a bike somewhat more often than other people do in the world. But we also want to be facilitated when we go on the bike. So Deventer is also investing in new types of sensors, such as the camera of Venotion, where we can detect cyclists, and you see them here. It's a whole group, and when the sensors see a group of cyclists coming towards the intersection, it can decide by giving a higher weight to that group of cyclists to give them green light and leave the car standing for red light at that moment. And of course, this is a very high-speed video. Normally, they wouldn't cycle so fast, but it gives you an idea of how groups of modalities can be prioritized and support policymakers in achieving their, in this case, health goals. Well, to sum that up a little bit, this cycle policy was also evaluated by a third party, and these are some facts and figures that came out. And I think without the created ecosystem that we've done with Manoj and with Venotion and other parties that are involved in the Talking Traffic program, it was not possible to achieve these goals. So I think this is the perfect proof of the pudding that what we're doing is right. These are also some generic flow-tech results where we see that in some cases when throughput is an important policy aspect, then reducing stops is also an important topic for policymakers. Yeah, that sums it up, Paul, I think. Am I good on time? I think so, eh?
You're absolutely perfect on time. Thank you very much indeed. That was terrific. Again, I've been scribbling down loads of questions. You can put your questions in too on the Q&A on Teams, and a reminder that we're recording this. And so if for any reason some of your colleagues or clients haven't been able to join this webinar, you'll be able to share it with them in due course when it's published. Now let's move on to our final guest before we go to our discussion, and I'd like to introduce to you Christopher Halen, who is Operations Manager at vNotion, and some very exciting technology that vNotion have got, and he'll be sharing that in the next few minutes here on this webinar. So Christopher, over to you.
Thanks, Paul, for the introduction, and welcome everybody. Happy to be joining this webinar and happy to share what we can bring to this CITS world. We've been talking a lot on intersectional level and on different types of traffic, and usually these intersections are controlled by traffic control cabinets. These cabinets receive information from ITS, from CITS, from connected vehicles, people using onboard units or connected apps, and it will control the traffic lights, improving the throughput or reducing the CO2 emissions, generally speaking, improving the policy of the city. However, it's very important to have good ground truth to base your decisions upon. So the main goal of vNotion in this ecosystem is to provide information about all traffic users present in the intersection. So not only the ones having the onboard computers or having the latest car models, but everyone present, the pedestrians, the cyclists, the cars, the buses. Everyone who's present will be detected and transmitted as a road user to the CITS application. And that will improve the policy making, as we'll see in a few minutes. First, a little background of vNotion. Our market is and has always been traffic observation using smart AI cameras. We've been established in 2007, and in 2011 we started with our first commercial outing, the people counting, focusing on pedestrians and cyclists during events and festivals. In 2014, we introduced motorized vehicles as well. In 2016, we launched our first standalone product, ready to be used by anyone. And 2 years ago, in 2021, we connected our applications to the smart traffic lights, giving broader access to our data to everyone connected. This is how our technology looks like. It's a very small card at the bottom right, and that's where all the video processing happens. We use embedded AI, which means that this card is physically connected to the camera and locally processes all video and then removes the video and only leaves the traffic data on the board unit. It can be mounted both indoors and outdoors based on your preference. And as said, the traffic data remains and will be broadcasted to Manoj and then on to different partners like Royal Haskoning DHV. On the bottom left, you can also see different traffic users. You can see the pedestrians, the cyclists, the scooters or the motors, cars, trucks and buses. Those are all different types of traffic users that we can detect, classify, and send over to the CITS application to be used in the policy making. To give a bit broader insight in our architecture, as said, the card, the AI chip is connected with the camera. It will decode the image. The image is left out and then only the objects remain. Those can be any traffic object, and using these detections we can extract different information that can be used, like their speed, their GPS positioning, their direction of travel, of course the traffic type and the distance between each traffic user. That will be stored in our database and also sent out using our API this is done in two manners. One is that we provide a graphical user interface at which you can access the count results, seeing a trend analysis, historical data on the busyness of the intersection. And secondly, we also send out COM data to Monodge, to their traffic light exchange platform. And that's being sent through to, for example, Flowtech, which is using the data that we provide to better regulate and govern the traffic lights. So you might wonder what's COM data. That might be a new term for most of you. COM data is an ETSI standard, which stands for Cooperative Awareness Messages, used in the autonomous world, but also used in the CITS applications. We generate these messages for every traffic user every second, and it includes their traffic type, their speed, their GPS positioning, their direction of travel, and their detection time. And using this information, you can apply different policies, different government rules, but this will provide the ground truth of what's happening at your intersection without a dependency on the traffic user themselves. These are some installation examples of our sensor. When there's 24/7 power available, you only need to install a small camera on the top and a small processing unit at the pole. If there's night power present from public lighting, you can install a small cabinet at the bottom, which is incorporating a battery pack. This will be charged during the night using the public lighting infrastructure, and during the day it will provide the power to our sensor. Or if you want a complete standalone solution, there's also a solar powered solution available. To sum up the benefits, we can include a very high area, up to 80 meters width and up to 45 meters depth, all using a single smart traffic camera. We can detect 99% of all traffic participants, just not the ones hiding behind the truck. Our GPS is very accurate, up to half a meter. We are not dependent on cell reception accuracy or mobile GPS antennas. We provide the same GPS accuracy for all users using our technology. As said, images are not stored, so we are privacy by design. And we provide all COM messages within half a second, so the traffic application can act as quickly as possible. Now, how is this technology used in practice? I have 4 different examples for you all. The first is extended green light use case, where they want to use sensor data to extend the green light for different road users. There are different sensor technologies are compared, mobile apps, connected vehicles, and smart cameras. The results are that cyclists have a 5-second reduced waiting time using this available data, this available ground truth. And compared to the other technologies, we provide the best coverage as we provide data on all traffic users. And we also provide the best GPS positioning. And the last is best seen at the picture on the right, where you can see the red lines being all the GPS positioning that we provide using our sensor. And the green and blue lines are all the lines scattered across the intersection from the different other sensor technologies, which are dependent on mobile antenna usage. The second use case is about bike platooning. Of course, we are also present in the Netherlands, at which bicycles are present a lot. And the government wanted to stimulate cycle platooning, both for safety, to reduce the speed differences between the cyclists, and also to optimize the green light for these cyclists. Here also very good results. When asking the participants how they experience the sensor, 65% wants to have this solution in the entire city. And there's a reduced green cycle time of 9 to 14% for cyclists. And it's very present in the rush hours, especially in the morning, where you can see a very distinct drop in the cycle times for the cyclists. I must mention also that the impact on the motorized vehicles was very limited as well. Because of this ground truth data, the intersection could be optimized better. The third use case is on prioritization, again on cyclists. But this is based on ETA estimations, estimated time of arrivals. You can see a detection area of the camera at the right. And we predict the estimated time of arrival of these cyclists when they arrive at the traffic light. So when a fast cyclist will catch up upon some slow cyclists, they will all arrive at the intersection at the same time, and we can optimize the green light schedule based on this information. Because of this approach, we have realized reduced waiting times of 20 to 40%, and again, a very reduced impact on the motorized vehicles as well. So again, a very promising result. And lastly, we are extending this technology also to other road users, like the motorized vehicles and the pedestrians. As mentioned before, we can provide information on them as well. And together with Roya Haskonen and DHV, we want to prioritize and optimize the policy goals here, using all information present, motorized and the vulnerable road users, to reduce the CO2 emission and to enhance the throughput. This will be done using the data from the sensors on the left and the right, a little bit ahead of the intersection to receive the information in a timely manner. Also, we have information on the intersection themselves, because some signal groups receive priority or receive a green light at the same time. And on the intersection, they need to wait on the different groups to pass before they can cross the intersection. These conflicts are present, but to provide information on these conflicts, you can better schedule the green lights of the other conflicting groups and ultimately improve the safety at the intersection themselves. All right, that's it for my part. Back to you, Paul.
Great stuff. Thank you very much. It's been a fascinating 45 minutes that we've had hearing about all these brilliant new innovations. It's now your turn, Mr. or Mrs. or Miss webinar participant, to join and take part in the webinar by asking your questions in the Q&A section of Teams. While we're doing that, I just want to bring all our guests back in now, please, and I'm just going to ask some questions. I mean, first of all, Steve, I just want to start with the fact that when you need to build a business case for investing in new technology, you need numbers, you need some sort of evidence that what you're going to introduce actually will work. Now, Stephen talked about the fuel savings from the system for trucks, the half a litre of fuel every time a truck stops. Do you have any statistics about the value of TLEX and how it improves congestion, safety, air quality, whatever?
Well, sure. And I'm glad you mentioned Stevens, because those were some pretty impressive stats. And also with the asterisk that, of course, when you mention an outcome, then there's questions behind the questions regarding the sample size and the applicability and all that. So we're in an audience that understands that. We experienced a reduction of 10% in travel times for those participants that had absolute authority. And among those that had conditional authority, they experienced 26% fewer stops. So you could see that that there is a distinction between absolute and conditional. So it does bring to the surface, I think, the value of having different grades of prioritization and road use policy determined by the type of user. I think one other interesting outcome was that 60 to 90% of the road users that were contacted claim to have adapted their speed due to in-vehicle notifications. And this had largely to do with what's referred to as end of queue. So when they were alerted to the fact that traffic was bunching up and were given advanced warning, most people took advantage of that. And certainly that's an improvement in safety as well. So that's what I've got to share with you, Paul.
Okay, now before we move on, I just want to check one other thing where you say about, and you touched on in your presentation about the in-vehicle notifications. You said announcing data in vehicles. Now, the issue is, of course, that you've not only got to have the data to put into the vehicles, but you've got to have an ability for the people within the vehicles to receive the data and then to actually use the data that they can have, even if they've got the
Right.
equipment. They might not do so. How are we doing this, or is it a case of kind of build it and they will come?
Well, it's I mean, I think it is a progression that's occurring in both places simultaneously. So today, virtually everyone is carrying a smartphone. So applications such as Flitsmeister in the Netherlands or Waze in the States and also elsewhere in the world are great ways to bring information into the vehicles. I think now that the public mobile network can deliver quickly and reliably this kind of information, the automotive OEMs are taking this very seriously because, of course, the vehicles are already connected in order to deliver infotainment services and in order to update software. And so you've seen recent announcements, for example, where Haas Alert has made an arrangement with Stellantis, and they are bringing road worker and construction information into the vehicle in a number of production vehicles shipping today. So this is happening, and I think that you'll see it happening very quickly now that the feasibility is being demonstrated. For a long time, the industry was held back by other visions of how information would get to vehicles, and meanwhile, the public mobile network has become very, very capable, and we're now seeing instances of this.
Okay, thank you. Stephen, I just
Sure.
want to ask about FlowTac, and the impression I got was that actually you can cope with differing levels and quality of data, but how important is it to have data through the TLEX system to really maximize its value?
Well, it's actually the only reliable source data that we get, because we only use data that comes from TLEX because it's certified data. So there's no other party can join the TLEX system, the ecosystem that we've created, without being certified. So that gives a certain quality guarantee, but also privacy guarantee.
Okay. And
If Paul, if I might,
Yep,
if I might
certainly.
just jump in on that, having the data come together as it does within TLEX is an opportunity to monitor the quality of that data as well. So you can set policies around parameters and monitor those parameters. So something as simple as a traffic light controller getting its clock misadjusted creates an enormous amount of bad data. And so picking that up quickly is an important part of what the system can do. And this becomes especially important when you talk about a regional or a national system. There's no way that humans can do this. So you need to have a system that's organized around this. And further, as I mentioned, the system can also then look at the success of the outcome. So while Steven's technology might be making great decisions, we're able to say, well, here's what happened. How did we respond? And we're able to look at that in aggregate. And so not only monitor the quality of the data at the data level, but also at the application level.
Yeah,
I think that also gives an opportunity to answer the question that we've got in the Q&A from Erik Jan Pruim. What happens if one road user is detected by a camera, by his app, and through his in-car system? Within Flowtech, we have an algorithm that validates this kind of checks. So maybe you know the example of the Japanese person that had 150 Google telephones with his Google Maps open and driving on his bicycle to a street to create a virtual traffic stop, but it wasn't there because he just had 140 phones with him. Well, those kind of tricks are not possible when using Flowtech. We have certain validation and filters that filters out these kind of duplicates without touching the privacy.
Fantastic.
Yeah, just to
carry on. Yep.
Yeah, just to provide a small addition on this as well. In the cooperative awareness messages that are being sent, there is also a vendor identification. So while it may not use in the case of having 100 identical mobile phones from the same vendor, it can be used to distinguish between the messages from the smart cameras and the mobile phones as well. So within Flowtech, it's possible to select your preferred data supplier on specific intersections, so you can pick the best source for your decisions.
Now, stay with us, Christopher. I want to ask you a bit more detail on your green light optimization for cyclists, because usually when you start to prioritize one user, there'll be a winner and a loser. But you were saying that actually you've massively improved the lot of cyclists, but you've had a minimal impact on motorized vehicles. How's this worked out?
Well, I think the most simple way to answer this question is to provide you with an example. If you have an intersection where a cyclist will arrive every 10 seconds, for example, it will press the button or it will ride over an inductive loop, and the green light will be scheduled for this individual cyclist. It will stop the motorized vehicle in that process, and it will happen again and again for each coming cyclist. If there is a way to see that there's a bigger group of cyclists coming on, or if their estimated time of arrival is similar, you can bundle this green light, or you can extend a little bit of your green light phase for the upcoming cyclist without having to request an additional cycle for your green light phasing.
If I can jump to it also from our perspective, the optimization of these data sources, and it's also because we get it's not now it's when a cyclist pushes a button, we see it and it's already at the intersection. But now with the Venotion system, we get data much earlier, so we can really plan it in. So then we find space in the system to give them green light, the cyclists, without cars affecting it. So that has also something to do with dynamic optimization in that sense.
Fantastic stuff. Now we go back to my first question. Actually, this is Lee has asked this question, and it kind of fits in with one of the big challenges you always come across in our industry, which is that the benefits are kind of fairy gold. They just help the economy, less congestion, less emissions, fewer emissions. It's great, but it never appears on anybody's accounts, on anybody's spreadsheet in a traffic control department. So they've got the cost, but not necessarily the benefit. And Lee's picked up on this by saying, who's investing in this technology? Who's paying for it, and what's the business model?
I think we all have our different kind of business model. I can tell you about ours. I mean, our main clients are road authorities, and that could be in the Netherlands. It's a local authority, so a local municipality, but also provinces in the Netherlands, so states in the US, for instance, and also countrywide. What we see that our Ministry of Infrastructure, they decided to create the ecosystem, the Talking Traffic program, and from there, of course, purchased the TLEX software, where we all come into play and where we can provide and get data from. Our service, the Flowtech service, is we sell it directly to those road authority or local municipalities, and it will not give them a benefit in money wise, but they have a tool in hands where they can operationalize their mobility policy, and they didn't have that before. So now they have the opportunity to make sure that the right modalities are prioritized, but also that their mobility goals are being met. And that's, I think, the biggest advantage for those kind of local road authorities, but also nationwide authorities, is that they now have a tool in hand with a complete ecosystem behind it, where they can effectively get their mobility policy to the street.
Mm-hmm. If I might, Paul, as well, I think this is it's a very good question. I would observe that the roadway authorities have been procuring silo type solutions, and what we're talking about here is breaking out of silos, but it still is an expense for the roadway authority that we're talking about. So our business model has the roadway authorities procuring this foundational digital layer to provide interoperability, and it would be, say, priced according to the number of connected objects and so on. The benefit is that it not only reduces their costs because it simplifies various integrations, it reduces the friction to implementing more and more of these services, and most profoundly, it puts them in control. They're controlling their roadway policy across vendors, and no one's getting locked in. So it unleashes a marketplace of services as you look forward in the ITS journey, and I think in our experience thus far, that's a very, very welcome change.
Now, the word silo has come up quite a lot in our discussion in the last hour, and I remember stories of putting together the Easy Pass on the east coast of the US, and the difficulty wasn't apparently the technology, it was actually getting individual authorities to actually work together and cooperate. Are you finding different authorities and sections within authorities are keen to work together and are welcoming the removal of silos?
Well, I mean, if you look, we've had a tremendous response to this. And if you look at the recent infrastructure legislation that provides SMART grants, the initial grant is to devise a system, and then you qualify to be considered for the second grant, which is to scale it out. And when authorities, this is a small sample size, but it's early, right? When authorities learn that by using this interoperability layer, their neighboring jurisdiction can use whatever technology it wants, it makes the decision process to create a regional solution vastly easier. And so in the environment here in the US, where we don't typically have the national organization telling the regions what to do, this is a very important functionality indeed.
Okay, right, we've got one more question we've got time for that I think is important because it's a practical one. Now, Christine has asked you, Christopher, to go into depth on the optical detection. I don't think we've got time for you to go into depth, but how does your system compensate for low visibility situations, weather events, that sort of thing?
Yeah, I think the main part of Finotion is to make sure it works in all different types of circumstances. It's very easy for anyone to apply an AI model and go with a happy flow, and it will work when it's very sunny and nobody is wearing any funny hats or riding all the same type of bicycle. But the main goal will be to apply it to harsh conditions, to shadows. Not only the regular cars, but also the mini cars or the vans or the trucks or the semi-trucks, the cyclists with 1, 2, or 3 wheels. I think that's the main added value of Finotion to make that possible, both by having enough data, artificially generated or in real life, of all different users in all different circumstances, as well as advanced technology understanding of the AI models to make sure that it can handle different variety of sources.
Okay, right, we're pretty much out of time, so very, very quickly, I'm going to go around the three of you. So we'll start with you, Christopher, which is, How much of a game changer is this compared to the years of cabinets not really talking to each other, not that much real-time data, loops in the road that would often break, etc.? When you're running the transport infrastructure in a city or a region, how much of a game changer is this technology?
For us as a sensor provider, it's a very big game changer. And it all has to do with the accessibility and the usability of our data. Before, and again, I mentioned the word silo. We are in a silo where we can provide a lot of ground truth and a lot of very usable and valuable data. But the way to use it by the road operator is very difficult. And with this technology, the bridge to other road users, to new road users, to everyone has been a lot easier and a lot quicker, which enables us to provide a lot more value while still focusing on our core proposition, which is to provide the best data possible.
Okay, Steven?
Yeah, so it's massive. I mean, we can turn around that, but it's massive, and we're still in Dutch we say we're still in child's shoes, so it's still early. What we see coming is that everything that moves will be connected with each other, and that data will run in the cloud, and we can benefit from that. I think in a few years, also with the autonomous driving coming up, this will radically change everything we know at this moment. So yeah, I think that the technology is ready, is becoming more ready, but now it's up to the municipalities and the road authorities to make the shift and to be brave and to invest in this, to go forward in different kind of parts of the world. And that's an invitation.
Okay, and Steve, we'll leave it with you.
Okay, well, I'd say this is a massive change. We've got in the very near term, Vision Zero, environmental consequences and congestion driving a need to do a better job with conflict management in intersections. So what is today kind of a binary view is actually, I think, as everyone will admit, is a really a very robust view that only becomes more interesting and complicated when we look forward to more autonomy and other kind of transportation solutions. So this is really a platform that enables today, but it really builds toward the future. And we believe it's truly significant.
Fantastic. Well, we in the UK are always proud of our intelligent transport systems innovations. And then we look over the water at the Netherlands and are always wowed about what is being achieved in the Netherlands. And this is another great example of something that's now spreading out around the world. And with my Highways News journalistic hat on, I look forward to keeping an eye on it and seeing the real strides forward in managing transportation that this technology can bring us. We are out of time. We could have chatted for another half an hour. So if you asked a question and it hasn't been answered, then our guests have said that they'll go on and answer your questions on their LinkedIn profiles. So go and find them on LinkedIn, link in with them, and you'll be able to continue the conversation on there. A reminder, this webinar is being recorded and it will be uploaded very soon and available for you to share with colleagues and clients. And we'll be back with another discussion on solutions to help us make the transport network work more efficiently, greener and safer very soon here with you. So for now, thank you very much to our guests, Steve, Steven and Christopher, and thank you for watching. And if it's the start of your day in the US, then enjoy the rest of the day. And if you're in Central Europe, then enjoy your evening. And thank you very much indeed for joining us on this webinar today.
Thank you, Paul. Bye, everyone.
Thanks, Paul. Bye-bye.